Merge that. The 2026 billion parallel AI agents are running up. Every parallel agent demo ends on the same frame, and the frame is a lie of omission. 3 sessions running, 3 diffs growing, a satisfied cut to the dashboard. The hour the demo never shows is the one that decides whether any of it was velocity. 3 finished branches, 1 main, and a human who now has to land all of it. The demo sold you velocity. What you actually took delivery of is inventory. That hour is where the productivity story goes to get audited. In part 1, I named the visibility gap, parallel sessions, nobody inventories. In part 2, I showed whose judgment catches what the dashboards miss. This part is about the narrowest point in the whole pipeline, the one the agents cannot parallelize for you, getting their work into main. The category needs a name too. Here is mine. Merge debt. The debt named. Merge debt is the accumulating gap between code your agents have finished and code that has actually landed in main, reviewed, shaped, and reconciled with everything else that landed first. It is not merge conflicts. Conflicts are the visible sliver. Merge debt includes the finished branch waiting 2 days for review capacity, the rebase nobody has run yet, the 3,000-line diff that arrived as one commit called update payments, and the decision no one explicitly owns, which of 3 finished branches lands first. Writing code got parallel. Landing code stayed serial. Debt piles up exactly at that seam. Any operations executive would recognize the shape on site, work in progress inventory, stacking up in front of the narrowest station on the line. Engineering has just not started booking it as inventory. The perception gap has a number now. The reason merge debt goes unbudgeted is that the people accumulating it sincerely believe they are ahead. Experienced open source developers completed real tasks 19% slower when allowed to use AI tools. Afterwards, the same developers estimated AI had made them 20% faster. METR randomized controlled trial, 16 developers, 246 tasks. Early 2025 read the 2 numbers together. The tools have moved on, and METR itself labels the result historical. The finding that survives is the direction of the error, a 39-point gap between felt speed and measured speed, in the cohort with the best calibrated instincts in the industry. Generating code feels like progress, with a precision that landing code never matches. So the generating gets counted, and the landing gets discovered. Now run that error at parallel scale. 1 agent inflates your sense of velocity. 3 agents inflate it 3 ways at once, while the landing pipeline they all share has not gotten 1 commit wider. The landing is serial. Here is the mechanical part, and it is arithmetic, not opinion. Work trees parallelize the work. Each agent edits its own copy of the tree. Nothing collides while the work is in flight, and that is the correct primitive. I made that case in part 1, but main is a single sequence. When 3 finished branches come home, 1 of them merges clean. The second rebases onto a main that just moved and pays for it. The third rebases onto both and pays compound. The wider each diff, the steeper the surcharge, and agent diffs run wide. Someone chooses the landing order or nobody does, and the order chooses itself. Whoever merges first wins the clean rebase, and the cost silently reassigns itself to whoever was slower to press the button. That is a scheduling decision with real engineering cost, and in most teams running parallel agents today, it has no owner. Merge order is set by button latency. I run agents through work trees daily across the 50+ public repositories I maintain, and the shift in my own week is the tell. The hours did not disappear when the agents arrived. They moved from writing the change to sequencing, shaping and reviewing what the agents wrote. The queue is where my time goes now, and the one gate every branch still has to pass is the one that did not scale. CI got faster and agents got better at making it green. Green CI tells you the tests you already had still pass. It doesn't tell you the change is right. and it especially doesn't tell you 3 changes are right together. The remaining gate is human review, and part 2 already showed what is happening to that capacity. The reviewers best at catching almost right are the scarcest resource in the building. Parallel agents do not add reviewers, they add queue. What the demos skip. The shape of what arrives at review is the other half of the debt. An agent that worked for 40 minutes hands you the result as one sprawling diff. Left alone, that becomes one commit, named something like update payments, sitting on top of a history that used to mean something. Git blame points at a commit whose message explains nothing, authored by a session nobody can replay. Put that in front of an incident review, the way Part 1 put untracked sessions in front of a SOC 2 walkthrough, and the aesthetic complaint becomes a forensics gap. The record of what changed and why ends exactly where the machine took over. Part 2 walked through the Git clear data on duplication rising and refactoring collapsing inside AI-era codebases. History quality is the same decay, one layer up. The code got wider and the record of why got thinner. At the exact moment, more of the code has no human author to ask. The market response, the tooling response to merge debt, is starting to ship, and in fairness to the argument I have been building since part 1, most of it is shipping on top of the commit graph. On the desktop side, Commit Composer takes the sprawling agent diff and restructures it into logical, reviewable commits before it reaches a teammate. That attacks the landfill problem at the right point in the pipeline, after the agent finishes, before review burns time on it. Auto-resolve with AI handles the mechanical class of rebase conflicts and explains its proposed resolution, which is the correct division of labor. The rote line matching goes to the machine. The semantic call, whether 2 changes are right together, stays with the human, because no merge tool can make it. 3. The pattern across both products is consistent. The vendor that spent a decade betting on the graph is now wiring the landing pipeline into it. Stated plainly, as always, Commit Composer and Auto-Resolve are part of GitKraken AI, which sits behind a paid plan, and both are in preview. And no tool in this section repays merge debt for you. What it does is make the debt visible and the repayment cheap enough to happen daily instead of quarterly. Pink this week. My concern is narrower. The queue. Control protocol. What managing merge debt looks like. At minimum, none of it requires believing a single vendor claim. 1. Give merge order an owner. If 3 branches finish together, landing sequence is an engineering decision. Smallest blast radius first or hottest file first, but chosen, not defaulted to button latency. 30 seconds of thought per landing, and the compound rebase tax stops being random. 2. Budget diff width per agent task. The wider the diff, the steeper every downstream cost. Rebase, review, revert. Cap agent tasks the way you cap PR size for humans, and split before landing, not after the review stalls. 3. Make commit shaping a mandatory landing step. Machine output does not get to enter history as one blob. Whether the shaping is done by Commit Composer or by hand, reviewable commits with meaningful messages is the entry fee to main. Your future bisect is the beneficiary. 4. Check the heat map before you spawn. 2 agents aimed at the same module is a collision you scheduled. The graph shows every active worktree and what it touches. 10 seconds of looking before launching Agent 3 is the cheapest conflict resolution that exists. 5. Plot the debt. 2 numbers per team, on the same dashboard as velocity, time from agent done to merged in main, and share of agent-authored code reworked within 2 weeks. The first is your queue depth. The second is your quality echo. Both are measurable today with the per-team measurement discipline this series keeps coming back to, and neither shows up in the commit count everyone is currently uploading. 3 questions for your next engineering leadership meeting. 1. What is our median time from agent finished to merged in main, and is it growing? 2. Who decided the landing order of the last 3 parallel branches that touch the same service? And was it decided at all? 3. What share of AI-authored code that merged last quarter was rewritten within 2 weeks? If those come back fast, your landing pipeline is instrumented. If they come back as shrugs, the debt is already on the books. You are just not the one carrying it yet. Your reviewers are. GitKraken Ambassador note. As a GitKraken ambassador, I write about the layer of the stack where engineering teams actually lose time, whether or not a tool exists there yet. Merge Debt is that layer this year. The graph-first landing workflow in GitKraken Desktop and GitLens 18 is the first commercial tooling I have reviewed that treats landing, not generating, as the bottleneck. That diagnosis matches everything I see in production, which is why it lands here. The adoption verdict, stated as a trade-off: if your team runs more than one agent against one repository, the Graph Plus Worktrees landing workflow is the part I would adopt this quarter. If you run one agent serially, you can hold. Your merge debt is small enough to manage by hand. And the part that repays the debt fastest, Commit Composer and Auto-Resolve, sits behind the paid plan in preview. That is the cost side, and you should price it against your reviewers' hours because that is the currency the debt is denominated in. Discussion. If you are running parallel agents and your agent done to merged time says something different, drop a comment on the post. Counter-arguments welcome, and the comment thread is where I respond first. For longer back and forth with senior practitioners, join the discussion on Discord.